large language model, that is LLMs. There are so much fuss, or there is so much jargon around LLM, but nobody actually knows what is actually going on in the behind the scenes of an LLM, like how it processes an input and how it gives an output. And afterwards, we'll also discuss something about GPT. Uh, what GPT is? It is a generative pre-trained transformer. It is the actual full form of GPT. We'll come back to it later. First of all, I'll tell you guys all the topics which we are going to discuss today. And after all this, we'll discuss the process of tokenization, how a input, or let's say a sentence is broken down into different tokens, and how are they embedded in forms of vectors. The most uh, hyped and the most important part, MCP. MCP, Model Context Protocol. It is just a protocol, but it has been hyped so much, and there is a lot of confusion around MCP. We will clear that out, and also we'll see a small demo on how you can connect to a MCP server. Okay, and we'll also discuss what is an MCP server, some MCP tools, MCP clients. Okay, and after that, transformer architecture, we'll just brush it up like high level design. We'll not go deeper into that because transformers is full of neural networks. uh, there are too many concepts of deep learning, so that for now we'll just discuss the basic outer part of transformers, so that you actually know what a transformer is and the difference between a transformer and an LLM. And afterwards just something about RAG, few things, few minutes about RAG, and also something about vector DB. First of all, what is an LLM? LLM is a large language model. You might have, everyone might have heard about it. So what are the different types of LLMs? It is, first things, the most important, ChatGPT. It is Claude. There is Gemini. There is Grok. There are many LLMs. These are all LLMs, large language models. So what basically is a function, or what do actually LLMs do? So you might think that whenever you talk to them, they just respond. But no, LLM is something different, because LLMs are a prediction model. LLMs are like prediction models. See, whenever, for suppose, I send a message called hi, how are, and that's it. So you know that what comes next, hi, how are you, okay, but the machine doesn't know what is next, right? So what LLM do is they predict the next word by seeing the sequence of the input which you have given. So whenever you give this input to any LLM, to any large language model, they predict it, and the response will be like you. So in short, if you send hi, how are you, it will respond something like I am fine. How does LLM do this? Because you might think it is just simple, you send an input and magically there is an output. But no, there is so much going on behind the scenes, because obviously the computer or the machine does not understand English. It doesn't understand Kannada, it doesn't Telugu, Hindi, Marathi, Malayalam. It doesn't understand all the human language, right? It understands only max, it understands zeros and ones, it understands numbers. So, how is actually an LLM predicting it? Let's see now. See, first, a user prompts the ChatGPT. Let's say the user is me. I am the user and I am using ChatGPT, because ChatGPT is an LLM, right? See, user prompts, I prompt LLM, ChatGPT, that please explain MCP in simple terms. I just type this thing, explain MCP in different simple terms. So what happens in the backend is This sentence explain MCP in simple terms is divided. It is divided and it is converted into different tokens. How these tokens are generated? It is all there are many algorithms running in the backend. Each LLM model, each AI model has its own process of dividing a sentence into different tokens. Uh, and we'll look into tokenization also deeper in a few minutes. So, in simple terms, this statement is divided into different tokens. It is converted into numbers. See, here explain is converted into 1, 2, 3, 4, MCP in 5, 6, 7, 8, in 910. See, these are all converted into number format because a machine understand only numbers. It understands only numbers. It doesn't understand our normal language. So, as you can see here, text is broken down into tokens. The tokens are divided in there are different standards for that. And after that, the next step is each token, for suppose explain is embedded, it is converted into vectors. Vectorization is another process which happens in the backend whenever you send an input to an LLM. See, first user sends a prompt, then it is converted into tokens. Those tokens are embedded in form of vectors. Okay, see, tokens are converted into vectors because vectors are something. So why we convert this into vectors? We'll look after that. We'll look into that. There is another diagram for that. You will understand that easily there. So and after this embedding, after the input is embedded into vectors, it is then given into a transformer. Transformers is the inner working layer of an LLM. LLM is powered by transformer. Okay, we'll also look into that later because you just understand that it is vectors are given to the LLM and LLM predicts the next token and the high for suppose we took here, right? Hi, how are you? What might be the next token? Next token is you, right? See, the LLM gives multiple predictions. For suppose you, hi, there are multiple token prediction, and in the token predictions, the most likely one which is about to occur is selected by the LLM. See, token selection, the most likely token is selected, and that is again because this token we cannot understand. Tokens can be understood by machine, but tokens cannot be understood by a human. So when we tokenize the input, we should obviously detokenize it. So next is decode and append, and this process is repeated multiple times until you get a reasonable output, and after that you get a final response. This is in brief how an LLM actually works. Okay, see, in short, if I want to say how LLM works is LLM takes your prompt, breaks it into tokens, understands the context using billions of parameters, and predict the next best token. And this process is iterated multiple times until you get a complete response. These are few key components in LLM. First one is obviously tokens. Tokens is the most important part, and vectors. Tokens are converted into vectors. Transformer, this is the most important part again. Prediction and the loop. Okay, this is how an LLM works. Okay, did you understand, or should I repeat, guys? Please respond if there are any doubts. Shall I continue? Okay, let's continue. Now we have talked so much about LLMs. We have talked so much about how an LLM actually works in the back end. First, before we understand what transformer and what is an LLM is, first let's say transformer is something which is the engine of the LLM, and LLM is the car. Without transformer, LLMs are nothing. LLMs don't work. Before, see, just a second. Transformers came. Transformers were came in 2017, but AI was there even before 2017. But uh, when Transformers when Transformers were invented by Google, it completely changed the game of LLM. It made the LLM more efficient. It made the LLM's response more efficient and more good. As you can know, when ChatGPT came in the early days, it was just minimal and it used to give few answers. It was not that practical and it was not that accurate also. After Transformers, everything changed in the LLM world, in the AI world. So Transformers is the main thing ever. So what actually is Transformer? Transformer is the engine and LLM runs on the architecture of transformers. And LLMs and transformers are completely different. LLM is a prediction model and transformer is powering LLM. Okay, okay. You might be confused, but I'll say what transformer actually is. See, first we give an input to it. MCP. Okay, sorry. MCP is amazing. An input is given. When an input is given, as I already discussed, that input is converted into tokens. Those tokens are converted into vectors. Those vectors are stored in a vector database. That is another topic. And what happens inside transformer is it is actually a very complex structure and it is a very complex thing. If you actually want to learn everything about transformers, you need to know ML. After that, you need to know deep learning, and you also need to understand the structures of neural networks, max, loss function, reduction function. There are so many things which you might know, which you should know to understand transformers, to understand how transformers actually work. So but see, these are embedding. Tokens are converted into vector embedding. Those are given to the transformer blocks. Inside transformer blocks, there are few things. There is a self-attention block, and there is a feed-forward neural network. And inside this, all the main thing of LLM happens. Okay, let me explain it to you just a second. So before you need to know about transformers, there are few things which you should understand. So we'll come back to the transformers again. See, we'll first look at the process of tokenization, then we'll look at vectorization, how all these things work, and after that, at last, we'll go to transformers architecture. I'll explain the transformer architecture in detail. Okay. So process of tokenization. See, as we said, input is in English or any other human readable format. For suppose there is a raw input. First, if we want to tokenize anything, first the text should be pre-processed. The text should be cleaned. For suppose we have I love AI and it has capital letters, uppercase, smaller case. There are all the stuff here. So text is first pre-processed and afterwards it is split into subwords. So it is split into subwords and after that those are converted into token IDs. Okay, it is if we want to know about tokenization from the top, it is a simple process. It is nothing but you take an input for suppose uh, let's I'll write it down here. Hey, I am Amok. See, we have I have one statement here. Tokenization is nothing but we divide this thing into different parts. Okay, so to make you understand a little bit more, I have a website for you. Okay, you can see it, right? Yeah, this is a website by Versal, Tick Tokenizer. It shows how each model converts their uh, state inputs into tokens. Okay, first of all, we'll look into the GPT 4.0. See, I'm typing, hi, I am attending. Hi, I am attending AI Understood Bootcamp. But see, this is just 1, 2, 3, 4, 5, 6, 7. This is just 7 words, but it has divided it into 15 tokens. See, as you can see, hi is one token, I is one token, am is one token, attending is one token, AI understood, boot boot is one token, and camp is one token. Okay, and these are the token IDs. For user, we have 1438. For hi, we have 12194. This is how a model converts its input into a token. We'll see it for Gemma. Wait. Okay. See, hi, I'm Amok. It has converted it into 8 tokens. Hi is one, I is one, am is one, AMO is one, GH is one, DESH is one, this is one. It has converted into 8 tokens, and these tokens are actually numbers which the LLM can understand. Is this clear, guys? This is the whole process of tokenization. There are some algorithms in the backend which converts these words into tokens. That's it. As you are we are not AI researchers, or if you want to actually become an AI researchers, you might need to know all the algorithms which are going at the back end. As you are just some software developers, as you just want to know what AI is, this is more than enough to know how tokens are generated. Okay, we'll come back to our diagrams. See, this is in simplest form. This is how tokenization is working, and similar to how we are converting our input to tokens, we should also convert the token uh, i- into normal English words also, right? Okay. The next is the process of vectors. See, why this vectorization is so important is, first we converted our input to tokens. But these are just random tokens. The machine doesn't know the meaning of these tokens. So you need to know the actual context, and you actually need to know the meaning of this tokens. The machine should understand this, right? So what vectorization does is, it takes each token and it converts into vectors. What vectors help us to do is, each vector helps us in understanding the semantic meaning. What is semantic meaning? For suppose, let me say it to you with an example. The cat is chasing the dog. See, this is a statement, right? This statement is first converted into different tokens. But if all these tokens are individually converted, there is no context, right? Because the will become one token, cat will become one token, chasing will become one token. So if this tokenization is done, there will be no meaning. And if you want to know the meaning, what is actually done is, let me draw the graph for you. Vectors are actually, there are multi-dimensional. The most minimum dimensions which an to vector database has is 512 dimensions. There are multiple dimensions. For suppose we have a cat here and we have dog here. Okay, we have cat is right here and dog is here. And as we all know, cat loves milk. And who l- and just a second. And dog likes pedigree. Okay, this is just common thing, right? Whenever we think about pedigree, we think about dog. Whenever we think about milk, we think about cat. uh, we don't think like that, but general purpose. Okay, see, we have plotted the cat here, we have plotted the dog here. In the similar way, we will plot milk here. These are in the opposite ends. Now, if I draw here, see, if we calculate the distance between cat and dog, there is some distance. We need not go in that distance. And distance between cat and milk, there is some distance. This is the we are going in the directions because vectors are directions, right? We are going in some directions, and if in the same direction we go downwards here, we will there is a high probability that we have pedigree here, because that is how vectorizations are done. Okay, okay, let me explain it to you with another example, right? First, suppose these are animals, right? These are animals, and here I'm writing hum I'm a human, right? Okay, I'll write here Amok. I'm a human. These are animals. These are types of animals. So let's say these are breeds and these are humans, and these are the things which they consume. Okay, milk is consumed by cat and pedigree is consumed by dog. Okay, for suppose if we take the again we take the distance between Amog and cat, there is some distance between Amog and cat. Okay, and if we go here, we have milk. And in the same way, if we go down here, we might have sandwich and we might have human here. Okay, this is just a vector graph. There is so much max behind it, uh, but this is the basic process of how vector tokens are converted into vector embeddings. Okay, okay, let's move on. Now, what happens in the what happened behind the scenes whenever you give an input? Okay, we have already seen it before. It is simple. We send an request to the LLM. The input is processed. It is pre-processed. The input is cleaned, then converted into tokens, then into vector embeddings. It is then given to the LLM, and the LLM predicts the next token. The highest probable token is selected. That token is de-tokenized into English format or human readable format, and it is added to the context and it is stopped. This is how an LLM workflow is going on. Nothing. You give an input, it is processed, it is converted into tokens, vector embeddings, given to the LLM, it predicts the next token, then it selects the highest probable token, then it is de-tokenized, then it is added, and you get a response. This is how simple how an LLM works. Is this clear, guys? Is this clear? Please react if this is clear, guys. Okay, let's move on. Now, the main part, MCP. So, what actually is an MCP? MCP is nothing but Model Context Protocol. You need not worry about it is a big thing. Let me write it down here. Model Context Protocol. So, this is a protocol or a set of standards which was released by Anthropic. You all know Anthropic, the parent company or the creator of Claude. Claude is owned by Anthropic, obviously. Okay, so what is MCP and how MCP actually works? See, as we know, LLMs are pre-trained. They are models which are trained on previous data or a set of training data. It can only generate response. It is a generative model. It generates response based on data which it is trained on. Okay, but for suppose if I want something which it is not trained on. For suppose, okay, let me give you an example of this. If I say, hey ChatGPT, um give me some information about the Spider-Man movie. Okay, this will the okay after this input is given to the ChatGPT will process the input and it will give me the information all about the new Spider-Man movie. Okay, this is simple. This is simply how ChatGPT works. Now, if I give another input saying, please book a ticket for Spider-Man movie. Now, what will be the response of ChatGPT? It cannot uh, it cannot book the tickets on its own, right? Because it is trained on previous data. It cannot perform actions. It can only generate response. So for this, uh, we create some servers, we create some tools, and this is how we can give ChatGPT few power. Not exactly booking tickets, that has not been achieved yet. I just gave you an example of how it works. So, what is MCP? For suppose I am the user. I am the user. I ask, I I request the LLM like Claude, GPT, Gemini to for suppose uh, book a flight of Indigo to from India to America. I send this request. I send this request to an LLM. What this LLM does is it sends another request to the MCP server. Which MCP server? In our case, Indigo. It sends a request to Indigo saying, I want the list of flights which go from India to USA. For suppose, see, it will go to MCP server. MCP servers has some tools and it will fetch data. It will send response to the LLM. LLM will work on it. And LLM will give the final response to you. Okay, so that is okay. Let me give another example. Okay, first suppose, hope you have all heard about Notion, right? Hope you have all have heard about Notion. So Notion is an open source software. It is an open source software, and ChatGPT doesn't have an direct access for Notion. What we actually use Notion is for, we use it to take down notes and some pages. It is a high-end tool to take down notes. You can understand it simply. Okay, and I want what I want my ChatGPT to do is create a page in Notion and fill it with some information. Okay, what it will do, I'll send the ChatGPT this input to create a Notion page and fill some content in it. What this LLM will do is it will go to the MCP Notion MCP server and it will send the request to the MCP server. And what this MCP server will do is it will go into the certain tool which says that uh, which says create a Notion tool example, and it will give the response back to LLM. It is just external external power for a LLM. We can say it in easy way. Okay, let's go ahead. Let's move ahead. Okay, see, uh, RAG. What is RAG? Retrieval augmented generation. Most of you might have heard about it, but RAG is the most important thing and the most complex thing also. But you can understand it easily. So, what this does is we have LLMs like ChatGPT. For suppose, let's take an example. I am a private company and I have my private files and my private documents which I cannot share it to any AI model, obviously because of privacy concerns. But I actually want to use the power of LLM to grow my business. See, if you might understand, I want to grow my business with help of ChatGPT, but I don't want to give my private company information. So here where the RAG workflow or RAG comes in place. What RAG does is, let us understand with a simple diagram here. For suppose I am the user, I am the company HOD, right? I ask a question to LLM. What LLM does is, no, for suppose I have a customer service company here. This is the user and this is the company chatbot, and it has access to all the documents, all the private documents of my company. It has all the access to my documents. So these all documents are stored in a vector database, but this is also an LLM, right? Because a ChatGPT is an LLM. Okay, what this user does is it sends a request to my chatbot saying, uh, why is my flight delayed? Let us take an easy example of Indigo, right? Indigo Airlines. Indigo Airlines has their own private information which they don't want to share to the ChatGPT or any LLM. For suppose they have a chatbot, and I, as a user of Indigo, I have booked a flight on Indigo, and I want to know my details, my timings of the Indigo flight. So I'll ask the chatbot, uh, why is my flight delayed? Let's say, why is my flight delayed? I want a refund, or I want to modify my timing. So if you give it to a normal LLM, it doesn't know the context, right? Because it doesn't know that you have booked a flight to USA or you have booked something. It doesn't know because it doesn't have access to the Indigo server. So I asked the Indigo chatbot saying, why is my flight delay and I want a refund or I want to modify my timing. So what this chatbot does is it has access to its internal documents, right? It has access to internal documents, and it will look like for suppose, the what are the main points here? Why is my flight delayed? I want a refund or modify my timings. There might be different documents saying a document for refund, a document for modifying the timings, document for flight delay document. So what this chatbot does is it fetches all the documents, it sees the documents, and it gives to the LLM along with the context, and you get a personalized uh, personalized output, sorry, you get a personalized output. That is how in short an RAG works. Okay, let's see it again here. See, user sends a query, the LLM or the RAG system searches relevant information from its knowledge base, and it augments. What is augmenting is uh, the related documents to the query, and the query itself, it is sent to an LLM. See, here. Combine retriever information with the original query, and it is sent to a LLM to generate app response, and the response is here. This is how a RAG pipeline or a RAG workflow is. What we have in our knowledge base, we have raw data. First, we have raw data. For suppose we have our PDF files, company servers, information, SQL databases, everything about our company. We have raw sources. First, we load and extract it. We load and extract all the data. Then we convert it into different chunks, and we create the embeddings, vector embeddings, and it is specifically stored in a vector database. RAG is built on top of vector database. Okay. Nowadays, there are some things called as vectorless databases, but those are still complex and not completely in production. If you want to create a production ready RAG system, you should know how to create a vector database and how you should create data. Okay. See, there are types of RAGs: naive RAG, advanced RAG, and agentic RAG. There are multiple usage of RAG in LLMs. We have discussed everything. Okay. Okay. Now a very good example of how we can embed or how we can use vector database and ChatGPT to create a RAG system. Okay. For suppose you will understand this very well. See, we have for suppose I am a, let's say I am a YouTuber. I'm a educational YouTuber. I'm not actually, I'm just giving it as an example. I'm an educational YouTuber and I have multiple YouTube videos. I have multiple YouTube videos in my channel and I want to create a website on it. So I create a website. I have uploaded all the YouTube videos over there. You can access every single video in my website. And what I do is there are multiple of my students and there is a section called doubt section. For suppose uh, a student asks a doubt for suppose about MCP, because if we are doing everything manual, a human should reply him. So instead of a human, we have created something called a personalized tutor. Okay, what we did is first of all we took all the YouTube videos and we converted into the transcripts. We extracted the transcripts and we converted the transcripts into chunks and into vector embeddings, and we have stored in a vector database. Okay, for suppose our vector database is a neon db. Okay, this is first step to create an AI tutor, like personal tutor who solves your doubts. Okay, next question is, for suppose there is a student here, he has a doubt, what is propagation in neural networks? First user asks the question. In the backend server, the query is received. The embedding of the query is done because it is converted into tokens and into vector embeddings. Those vectors are searched in the Neon DB, our vector database, and the relevant video transcripts are retrieved. This is a RAG system. The relevant things are retrieved from here, and along with the context from the RAG and the query, we send it to ChatGPT. Now ChatGPT has the context of what actually is back propagation, all the information about my YouTube videos, and the original query also. It has context plus user question. And with this help, ChatGPT gives a very accurate response and very high quality response. This is how you can use vector databases, RAG systems, and LLMs to create something. This is actually a production ready pipeline here. Okay, I have taken it from a YouTuber and I have converted it into a diagram. It is actually a production ready system here. So let's move forward. Now the main thing here, we are going in the thing of AI agents. Okay, just a second, guys. Okay, So everyone might heard of AI agents, agentic AI, agentic workflow. There are many things around agents, and there are so much confusion between what is actually an agent, what is actually just a chatbot. Okay, now don't need to worry. I will clear everything. So let me give an another example. Okay, so what is an LLM? We all know it is a prediction model. It is a prediction model, right? Okay, it is a prediction model. And what agents is like, so if you go to ChatGPT, which is an LLM, and you ask, um, hmm, okay, I go to ChatGPT and I ask, book a Indigo flight. No, not a Indigo flight. We'll take a programming example. We'll say create a full stack application and create all the files. If if I give this query to ChatGPT, what ChatGPT does is ChatGPT can only give the code. It cannot create files for you. It cannot edit the files. It cannot write in the files. This is the main difference between a generative predictive model and an agent. Agent is different and ChatGPT is different. Okay. If I go into very deeply, ChatGPT is also agent. Currently, the ChatGPT which we currently use, it is an agent. It has all the access to the modern applications and modern websites because OpenAI has been continuously upgrading ChatGPT. So ChatGPT can actually do these things now with help of codex. And so if for suppose if there is a naive example, naive definition of what an LLM is, for suppose LLM is the brain, but it doesn't have hands. It cannot perform any action. It cannot perform action. Yeah, it cannot perform any actions, but it can give you any information. It may be about cancer, it may be about health related, it may be about data science, it may be about data structures. It can give you the whole world full of information. But if you ask it to do something, it will say no because it doesn't have hands. Agent, on the other hand, it is brain with hands. Okay. Agent is nothing but it is an LLM with hands. It can actually do things. It can actually create a file. It can delete a file. It can rewrite a file. It can edit a file. This is the main difference between agent and an LLM or a prediction model. Okay. Now, if we go into the deep working of agents or what agents actually have is, see, first there is a user. Similarly, everything has an user. User gives an input to the agent. Inside the agent in the backend, LLM is the main part of agent. Without an LLM, agent can there is no agent actually without an LLM because LLM is the brain. Without information, what can you actually do? Right? You cannot do anything with LLM without the brain. So LLM is the main brain. It can actually think. It can actually uh, generate the things. It can think, it can reason, and it can decide what to do next. It is smart. This is what actually makes an agent smart. And afterward, we have memory. Memory is the main part in agents. So why memory is important is because for suppose if we ask now ChatGPT, what I did 2 years ago. LLM doesn't have any information. If you create a new chat, all the information is gone. There is no older information of you because LLM doesn't have any separate memory. But agents have separate memory. It stores informations and past experiences. It stores every single thing. This is what makes agents very big thing. This has memory. And apart from that, the main thing is toolbox. Toolbox is nothing but functions. There are handwritten functions which actually tell what the agent can do. For suppose, let us see that also. And these three things are constantly running in a loop to produce a better output and produce a good response. Agent returns the final answer of result. So you might have seen if you have used anti-gravity or emergent or um, let's say cursor. If you have used any of these things, first whenever for suppose I give cursor a prompt saying build me a complete web app of a stack. Let's say a stack. What it will do? What that agent will do is first it will understand the problem what the user wants, it will understand it. Then it will create a plan. Then it will execute the plan step by step. We can see all this process whenever we talk to cursor. If you might have used it, you might have know it. Okay. So what is an agent workflow? It is nothing. So this is the most important thing. Perceive. Perceive is it can receive input from the user. This is what an LLM actually does. It should understand this this thing LLM does. This is the work of LLM. For suppose if I say build a to-do app, it should understand. LLM understand this and the LLM plans and it reasons what to do, what not to do. Then the action part, this goes to the tools. There are some tools for every agent. For suppose we have a programming agent, there is a tool called create a file, there is a tool called delete a file, there is a tool called edit a file, there is a tool called uh, remove the file. Okay, these are the things. Agent uses a tool from the toolbox to take actions. Then it will observe its own doing. First, there is a one iteration of all these four things, and after that, it will observe what it has actually done. If it is satisfied and if it thinks it is correct, it will continue to the next step. Otherwise, it will iterate until and unless it is perfect. Okay, and after that the result is stored in the memory for any future use cases, and this thing is repeated until and unless you finish the task. Okay, see, as you can see here, agent is equal to brain and toolbox and memory. It can use tools, it can remember context, and it can improve over time. Okay, goal is to help the user complete task effectively. Okay, this is how an agent actually works. So let's move forward. See, tools. We discussed more about tools. Now we'll see how a tool is actually called. First, suppose let's say the user has requested something called "What's the weather in Hyderabad?" Okay, it will ask the LLM. See, if you ask the if 3 4 years back, if you used to use ChatGPT and if you say what is the weather today, it will say I am not up to the date and I cannot actually access the weather information right now because at that time it was not an agent. Now ChatGPT is an agent. If you ask ChatGPT now what is the weather in Hyderabad, it actually answers. Okay, it says the user is sent a request. LLM understands the query and decides a tool. So if we wants to know if the LLM wants to know the weather, it should call the correct tool. So there is a tool called get weather. LLM generates a structured request and it will execute the tool and the tool will respond and the tool output for suppose Hyderabad 29 degrees cloudy is sent to the LLM, and that LLM gives you the output. See, tool result is given back to the LLM, and the LLM gives you the response. This is how a tool is used. Okay, these are the different types of tools: AI, API calls, database query, calculations, file operations, communications. These are the components of agent, LLM tools, tool execution.